Hello, everyone, and welcome to this podcast. Hello? Hello, everyone? Yes. Okay, so I think we are in business. Hello, and welcome to this webinar about how to understand what is a robot fleet management system and if you need it in your project. So my name is Ricardo Tellez from The Construct, and we are delivering classes and webinars and workshops, tutorials, trainings about fleet management systems, and that's why I can tell you a little bit what is this kind of software and if it does apply to your software project or to your business itself. Then let me share with you this presentation. So I'm going straight to the point. And yeah, so let's go and let's understand what is a robot fleet management system. And the first thing I would like to tell you is about this news. This, wait a second, where I am. Yeah. This news that I saw on CNN, it's about the Changi General Hospital in Singapore, who was deploying at that time, 1 year ago, more than a year ago, about 50 robots for their staff. That's awesome, right? And what were those robots doing? Well, they were doing a lot of things. They were, for example, delivering food to the patients, delivering drugs. They were cleaning around, transporting materials, and other tasks that are not related to robots moving around, like, for example, robots helping people that cannot move, so entertaining the people that cannot move, or making them do some exercise by moving arms and so on. So those are different types of tasks, but the ones that we are interested are the ones that I'm talking here about: delivering food, delivering drugs, cleaning, transporting material, etc. It's about robots moving around, right? Then when we have this kind of task, then this problem appears. So how can we orchestrate all those robots that are each one with a different task at hand? And well, maybe they are equipped into groups that deliver the same task, the same type of tasks, but they have to coordinate between all of them. Rather, they are delivering the same task or doing a different task. So how can we coordinate all those robots, all those different robots doing different tasks in such an environment, right? That is an environment that contains people around, contains doors that need to be open, contains floors that need to be changed. The robots need to change from floor to floor. And we want to deliver this task with the robots, trying to have as low downtime of the robots as possible, also preventing robots interlocks, which is robots colliding at a certain position, so at a certain location of the building, and then the robots, no one can move because it's waiting for the other to move. So they get locked at some space. And also without taking too much time to deliver a task. So how can we do that? Well, in order to do that, we need to decide in some way in the software, we need a software that decides which robots are going to serve which task. So which are the robots that are in charge of delivering the food? So from those ones, which one is going to serve the specific lunch for room number 25, for example, from all the robots available that we have. Then this robot that has to serve food to room number 25, which path must it follow in order to reach the room 25 as soon as possible? Then also we'll have to open doors, take elevators, or control any other things around in this material. For example, it has to interact with the food delivery system. And which robots, they need to go to charge, because by delivering doing tasks on a hospital or an environment, then the robots will lose the batteries. So we need to have a system that takes a decision about all this. And also this software has to be taking into account different types of robots involved in all those tasks. For example, in this picture, we can see an AMR, an autonomous mobile robot, on the left. Then we have an armed robot also, maybe it's involved in some other task. And then there is a drone also that has to deliver the medicines to another place outside of the building, let's say, for example. So this coordination software has to take into account, has to be able to manage different types of robots. It has to be able to manage different type of manufacturers. So that means that for the same type of robot that is going to deliver the same task, maybe we are buying one robot from one brand and then another robot from another brand because we buy it 1 year later, and then this robot is, the new brand is better conditions, better whatever, but we want it to work doing the same task, delivering food, for example. So we need to be able to manage those different systems from different brands. And also, we need to make able this software, this coordination software, to be able to take into account the interaction with other machines that are in the environment. Like, for example, the elevator that we can see on the left-hand side picture, or, for example, a door on the center, or maybe a conveyor belt or an armed robot there. So those are elements that are not robots themselves, but that the robots need to interact with. So the software that takes into account all those things and coordinates the behavior of the robots in order to accomplish the task is what we call the fleet management system. So the fleet management system or fleet management software is the software that connects. This software connects to all the robots that our fleet, our group of robots connects to each robot and then captures its status. Its status means different things. One thing could be the location of the robot in the map. Another thing is the battery status. Another thing is the status for if it is serving a task or is a stop available. And other things that the status can imply depending on the task. Then the fleet management software will decide which robot is going to serve the next task. So it's the one that will try to figure out which one is the optimal robot to deliver the task based on some constraints. For example, time, or closer to the location that needs to be done the task. Then it also is going to decide the optimal route to avoid collision between different robots. So it's going to decide each robot in which route around in the building or in the space that it has to work, how it has to move, in order to prevent two robots or more robots being congregated on the same point at the same time. So creating an interlock there. Then it also is the one that decides you need to go to charge now, so you are not available to deliver more tasks. Then go to charge and activate this behavior on the robot, so the robot goes to charge. And also is the one that will decide which elements are going to be activated and when. So it means, for example, a robot has to go to the other room and there is a door in the middle. Then it's going to decide that this door needs to be activated, but only when the robot is in front of the door. So that's the fleet management software. Those are the main tasks that the fleet management software has to do. Then in order to understand the fleet management software, I have divided them into two main types, let's say. It's my classification here, but it's in order to understand what is already available in the market. about this kind of software. So I have divided into two types. The first one is the fleet monitoring system, and the other one is the fleet management system. What do I mean about those? Well, the fleet monitoring systems, they basically provide the status of each one of the robots. So you can see the battery, the level, if it is moving or not available. In this picture, you can see also the temperature of the battery, the network signal, so many, many things, also cameras. And those fleet monitoring systems also allow you to remote control the robot. So by remote control, I mean that directly like a joystick. Some of them, they allow you just to push the robot to stop the robot. Or some other remote controls activities may include some more higher level activities like go to the kitchen, go to the elevator, in front of the elevator. So the fleet monitoring system do not allow to tell the robot a complete task to be solved. For example, deliver the food to the room 51. So you cannot provide this with this type of software, but you can, at some point in time, tell the robot to put aside from those panels. So that's the limitation of the fleet monitoring systems. You can see the status, you can remote control the robot, but this software is not going to coordinate the behavior between all the robots. So if you say to your robot to go to the in front of the elevator, maybe there are 3 other robots going into the same place at the ssame time, and maybe they will collide. When I mean collide, I don't mean to crash and to bump into each other, but I mean to be stopped in a door that they cannot move and a smaller space, and then they will be trying there all the time. They will be locked there. So that's fleet monitoring system. The fleet management systems are the ones that actually orchestrate all the robots, and also usually under changing conditions. Changing conditions, I mean that the robot available can change because some robots, they have been taken for other tasks. Maybe also the spaces available, the routes available, they are changing, so they will adapt to those and other conditions in the system. So the fleet management system is the one that is like a big planner that decides which robot is going to take a task at a certain moment based on the actual conditions of that moment. So you can see the two differences, right? Then as fleet monitoring systems, let me give you some examples of fleet monitoring system and fleet management systems. So as examples of fleet monitoring system, we have Formant. And here you can see one screenshot of their interface. There are many other screens there, so it's a very good interface for monitoring the status. And for example, another one from Freedom Robotics. That's another one, fleet monitoring system. And Brain Corp also has a fleet monitoring system. And that you can see here the route and the movements of the different robots. Then for fleet management systems, we have several packages there already available, but most of them, they are based on the robots of the brand that produces the fleet management system. For example, in this case, for Mir robots, so we have the Mir Fleet, which is a software that allows you to control and to manage a fleet of Mir robots, of different types of robots, but all of them basically are AMRs, autonomous mobile robots. Then we have, in a similar way, we have the Omron fleet for Omron robots. We have also Auto Fleet Manager from the Auto Robots. And you can see the different interfaces, very similar. They show a map, they show where the robots are, which are the routes, the places that they can go, no, or not go, the status of the robot, etc. This is for fetch core, for the fetch robots. Then I want to talk about the fleet management system standards that are appearing, because as all those previous ones, fetch core, auto fleet, on-run, and mere fleet, and others, there are more, okay, there are more. These are just some examples, but there are more. There are appearing a lot of fleet management system for a specific robot. Then there are some movements towards creating fleet management systems standard. It's a standard so that the fleet management systems can interactuate with any kind of robot. So they are not locked to a specific brand. Then this mass robotics is one of the standards for AMR's interoperability. But recently they have released the version number 1 with some limited results, but you can check it. So this mass robotics standard, how it works is that if you are a brand that produces robots and you want to adhere to this mass robotics standard, then you can make your robot compatible with mass robotics. So once your robot is compatible with mass robotics, then the fleet management system behind mass robotics can be used, or any other fleet management system that uses and supports mass robotics standard, then it can manage that robot from that brand. So mass robotics is trying to get as many brands of robots to adapt the mass robotics standard. So that's the strategy for mass robotics, right? Then in the similar way, there is the VDA 500, which is more concerned about AGVs, but can also be applied to AMRs also, of course. And then it goes on the same direction as mass robotics. So it's a standard interface and tries to get as many companies to adopt this standard. And one example of fleet management system for general robots, for any robot, is In-Orbit. In-Orbit is a proprietary fleet management system software that allows to coordinate fleets of robots from any brand. And In-Orbit also accepts the mass robotics standard. So it supports robots that are running mass robotics standard. And other robots, if you don't have an adapter for In-Orbit, you can create it. And then in a similar way as the In-Orbit system, we have the Open-RMF, which is an open source fleet management system. And then this one has a specific approach for providing fleet management system for any robot. So instead of following the idea of mass robotics, that it is to approach companies that build robots and convince them to use these standards, so they will be standardized to all those fleet management systems, Open-RMF follows another procedure, which is, we provide you with an interface that you can use to create your own adapter for any robot. So now it doesn't matter if your robot uses the mass robotics standard, if it uses its own proprietary system, if it uses ROS, it doesn't matter. Here is the template that you have to fill in order to create an adapter, and then once you create the adapter for your robot, then Open-RMF can use it. So, and this approach, I think, is more interesting because it doesn't require the companies that build robots to create their own adapters for this. So they can continue, companies of robotics or create robots, they can continue building their own robots, with their own interface. It doesn't matter what is their interface. Maybe it's a WebSocket interface. Maybe it's a REST API. Maybe it's a ROS interface. Of the Open-RMF is that it's open and it is built by Open Robotics, the creators of ROS. And in case that you would like to learn about Open-RMF, we are delivering at the Construct a 3 days intensive online training where we are teaching how to use RMF, how to adapt the RMF to your own project, like a warehouse. La batería, battery is kind of disconnected. Is it connected? Is it here? You can hear? Yeah? Okay. Okay, so you can hear me, but something happened with the laptop now. It started to, and I think it's the battery. Let me see what is happening. So, okay, so I think that we are back, and it's only. Yeah, so it's so now I think it's already running, and then the only thing that I wanted to tell you is about this course, and in case that you want to learn about Open-RMF, because we are training, and we have the link here beside. We have also created a complete cafeteria where we have different robots, where you are going to practice how to manage the fleet of those robots around, and you can see with different cameras the situation of the robots from your own computer in your own location. And well, that's in the intro about what are fleet management systems, and then I will be happy to answer any of your questions. If you have any questions on the chat, you can put it on the chat. I can see here one question that says, Amit Parmar, that says, is BDA 500 or BDA 50-50? Is BDA 50-50? Yes, it's right. Did I put it 500? Yes, maybe I was mistaken there. Then, okay, so any other questions? Yeah, so about the link to the class in the chat menu, let me add it here. We have this training by the end of this month, and then you can attend from your own location, and then you will be practicing with simulations with our real robots. We even have created in the cafeteria, you have the door. The door, wait a second, because I cannot find this, the link here. You put it, okay. Yeah, so you have the link there. There is a question that says, Amit Parmar, can we combine Open-RMF and VDA 500? Yes, you can. You can. So how would it work? So VDA 5050, it's, let's say, it's a standard of communication. So there is no fleet management on top of it. Then what you would do is to have your robot that supports VDA 5050. Then on top of this, you will create a connector that from one side talks to Open-RMF and to the other side talks to VDA 5050. That's it. That is the adapter that Open-RMF indicates. Then when you have an adapter in Open-RMF, what you have to do is to implement certain functions, and those functions are in order to get information from the robot and send commands to the robot. Those functions depend on the protocol, on the API that the robot provides. If the robot provides an VDA 5050 API protocol, then that's it. So this communication is made between the adapter and the robot in VDA protocol. If your robot is a ROS2 robot, then this adapter will have to talk ROS between the adapter and the robot with ROS2. If it has a REST API because it's another vendor that provides this communication protocol with the robot, then that's it. The adapter talks to the robot using a REST API. Let me see other questions. Amit Pamar says, it's like VDA 5050 as a schema for interface between robot and Open-RMF server. Correct, yes. Says, do you want to drive? Is asking, how can we use Open-RMF with free fleet in Gazebo? Oh, okay, yes, you can use that. Okay, so that's very technical now that you are telling me. That is possible to use it. So what you have to do is to, in Gazebo, your robot has to be running a navigation software there. For example, the ROS2 navigation system. So you have ROS2 navigation, and then you use the free fleet to talk to the ROS2 navigation system. That's the way to do it. But usually in Gazebo, what we use is the, what is called this one now? A slot car. So we use it's like a fake navigation system because it just simplifies, it simplifies the simulation. It's simpler navigation because it uses Gazebo exact positions. So it's a trick in order to simplify the navigation of the robot. But you can use it, and we have done it, and we explain in our course how to do a free fleet adapter for ROS2 navigation. Then Dimitros says, thanks for introduction. How ready is Open-RMF for a professional setting? So not just developing in academia or proof of concept scenarios, but actually running a warehouse production setting. Okay, that's a very, very good question, and it's a little bit difficult. My sincere opinion is that it is not 100% ready yet. It's progressing very, very fast, but it's not yet. So what does it mean? I mean, this system, Open-RMF, is being used. It's the system that is being used at the hospital, Changi Hospital, Singapore, the one that I have started this presentation, the news, that they had 50 robots there running. And they are using this system there, but of course, if you you download the code and then you create your own adapters and so on, you're going to find some things, some nuances, some things that need to be polished. And then that's the current situation. It works. You can use it. As you will see if you come to our training, then you will see that we have running this complete cafeteria. So we have robot moving from one place to another, asking the armed robot to prepare the coffee is put on the robot, then the robot serves to the door, to the table, then it goes to charging, and then it has to open the door to go to the area to clean some stuff, so it has to open the door, go there. What else? Oh yeah, you have an interface, a web interface where you manage everything, so you can command the coffees from web. So that is quite impressive. Okay, we had to do a lot of work for making this work, but it works. So that's the current status. And other question is, Sean Christian Anderson says, does Open-RMF work with ROS1 and ROS2? Yes, it does. So Open-RMF doesn't care what your robot is running. Internally, Open-RMF runs ROS2 internally. Then you can have a robot that runs ROS1 and then use it and connect to the system by doing the adapter that talks to ROS1. So you will be receiving the orders from Open-RMF in ROS2 format. Well, actually, yeah, in ROS2 format. And then you convert this into the ROS1 API of your robot. And so Amit Parmar says, can Open-RMF support secure-DDS where we have multiple domains? Okay, so that's very technical question, that deep, and I can tell you that I don't know the answer about this myself. Sorry, I'm not one of the trainers of the fleet management system. My team of engineers, they know a lot better. But what I'm going to do is to ask this question to them and then put the answer in the video comments below when I got it. Then Sean Christian Anderson says, do you use Leader, SLAM, or OpenCV and fiducial markers to tell the robot where to go in the cafeteria? Yeah, so in our case, we use a LiDAR and a SLAM, typical SLAM, for navigating on the cafeteria. And the robots, they can navigate there perfectly well. They use nav2 with ROS2. And yeah, so no problem at all. But you can use any type of navigation. You can use OpenCV, identifying fiducial markers, or even doing visual navigation, detecting features and so on. That is not strong for. So I wouldn't recommend this for a production solution, but also can work. Then Sarunav Tiagi says, can we manage the UAV by VDA 50/50? Well, I mean, unmanned aerial vehicle with this protocol. So the VDA 50/50, it is thought for autonomous guided vehicles, not for UAVs. So I'm not sure about that. I'm not sure. You should search more about that protocol and check. Then, do you want to drive? When we define routes in Open-RMF, the physical robots will follow those routes strictly or move more freely with nav2. That's also a very good question. So the routes, they are defined in Open-RMF in order to. It's like the lines that the robots are allowed to move. By having those lines to move, those paths, then you can make a control, you can make a prediction of where, if robots are going to collide at a certain point or not. And then the planner of routes of the Open-RMF can decide the best route for each robot based on its location, destination, and so on. Then, in theory, the robots can only move along those lines. But of course, if you are running nav2, then if the robot detects an obstacle in the middle, like a person that is moving, then it's going to plan around that obstacle, and then as soon as possible is going to return to the path. But the robot will be able to move away from that point if there is an obstacle in the middle. And okay, so far so good. More questions? So you're asking many technical questions here. I'm super happy. I'm able to answer you those technical questions to the point that I can. And then I was also waiting for questions about how to apply these questions to your, this Open-RMF system to your solution, if it is viable, see if it's a good idea, if it's a good business, anything about that? Any questions about that? Let's see. Okay, so I see that no more questions. Then in case that you have more questions, don't hesitate to put them below of this video, and I'll be happy to answer them as they appear here on the show, on the video show notes, questions below. Yeah, you know. Okay, we just received another one from Ivan Doria that says, do we have information on how much we can scale with Open-RMF? That is also a very good question. The answer is no, we don't. We don't have. This is the next thing that we are trying at the construct, trying to figure out. In theory, you can have hundreds of robots, but there is an error, there is a problem in ROS communication. So ROS communication is a problem, okay? So you can lose communication in ROS with many robots, with many Wi-Fi different networks, if the space is big and so on. So that is not something solved as long as I know, okay? So there is no report or anything. The only thing is the report that there are problems when you have many robots. But that's at the level of ROS2. That's at that level. Then in terms of Open-RMF, we don't know. In theory, there are, as I say, hundreds. You can have hundreds of them without a problem. But we haven't tested, and maybe that's a very good test to do it, for example, in simulation. Even in simulation could be a good test to do it. And we are going to do it and let you know the results. Sarubatiagi says, can we make a 3D map by LiDAR? Yes, you can, and make your robot navigate. So how your robot navigates, it's independent of the fleet management. The fleet management system doesn't care about how your robot gets from one point to another. So as long as your robot is able to go from one point to another by itself, when it's ordered by the Open-RMF, then the Open-RMF doesn't care how it reaches that point. For example, it could be an AGV vehicle where you have some, the AGV that are, they don't use a LiDAR or a navigation system. They just follow a line. So the Open-RMF doesn't care if your robot is having a full navigation autonomous system or is following just a line. And the robot cannot move outside of that line. Then it doesn't care, Open-RMF. So you can have your robot running a navigation based on 3D maps. Then Peter Deal says, how about the license? Can I use it freely? If you are talking about Open-RMF, yes, you can. You can use it freely because it's open source, it's made by Open Robotics with the same licenses as the other ROS and all the others, Gazebo and so on. So you can use it. If you are talking about the other products that I mentioned, which are proprietary, then you cannot. Or in Orbit, for example, Fetch Core, Auto Fleet, Omron Fleet, all those BrainCorp, Freedom Robotics, those are paying systems, all those. When we send a goal via Open-RMF, those Open-RMF send it directly to nav2. Okay, so this question means that something that you didn't understand properly is you cannot send a goal as a location to a robot using Open-RMF. What you do is to Open-RMF has a series of tasks and a fleet management system. Not only Open-RMF, but a fleet management system has a list of tasks that need to be delivered, that need to be done. So you can say at any point in time, bring the drugs to the room number 31. Okay, so then Open-RMF receives the order of bringing the drugs to the room number 31, and then is the one that is going to decide which robot is going to go to room number 31. So you are not saying, send this robot to room 31. You are not saying this on the fleet management system, okay? On a fleet management system like Open-RMF, you are not saying, send this robot there. No, you are saying, resolve this task, which is sending drugs to room number 31. Then Open-RMF is going to decide, oh, the best robot to serve this is this one because it's the closest, because it's the one charged with more battery life, whatever the reason. I don't know the reasoning inside Open-RMF has some criteria about that. Then it assigns this robot and then it tells, go to room number 31. And room number 31 is one of the locations here, for example, in this map, is one of the square, you can see here, squares. So those are defined locations for Open-RMF. So one of those will be room number 31. Then Open-RMF just says, go to room number 31. And then this translates into a navigation goal automatically. And this navigation goal is sent to the navigation system inside the robot. And then the navigation system inside the robot will bring the robot towards room number 31. And when it reaches that point, it will tell Open-RMF, hey, I have arrived. So what now? And then, so whatever. So the next thing in the task that need to be done. Then more question. How do you input the floor plan into the GUI of Open-RMF? Okay, yes, I cannot explain you that question now because it's very, so I had to show you and it takes a long time. Come to the training and we teach you exactly how to do that. That's the easy part of Open-RMF, very easy, very easy. Tommy, can we put RMF server on the cloud to connect different robots on the edge side? Any concern about this architecture? No, that works perfectly well, and actually it's how it works for our training. So in our training, each student is having a computer in the cloud, and then each student is configuring and preparing Open-RMF in order to connect to our robots in the cafeteria. So they are commanding our robots in Barcelona from a cloud server that has Open-RMF that the students, they have configured. So that's it. That's the way. The only concern that you have to have is the VPN. So you have to establish a VPN between the cloud and your robots on the edge. And then for that, we recommend you to use Usarion, which is the VPN system for robotics that we use. Usarion with H. Usarion. And Jeff Sosbe, he says, summary, Open-RMF has a toolkit that allows for uncomplicated entry of floor plans. Okay, no, sorry, Jeff, I don't agree on that. This summary is is getting many things so out. For example, yes, that it has this thing about having uncomplicated entry of floor plans. That is correct. And also has some plugins, for example, to create automatically from a floor plan to create the doors inside. It creates automatically a Gazebo simulation based on this floor plan and includes the doors, the elevators, as you have indicated in the floor plan. So they will run in the simulation Gazebo. So the doors will open, the elevators will move up and down and so on without doing anything for you. But more important than that, Open-RMF has the task planner also that decides which robots are going to be serving a specific action. Also has the routing system planner also, which is the one that decides which route every robot has to follow based on all the robots that are moving around and doing the different tasks, which are different parts, and many other things. So there are many other details, but those are the main parts, which are difficult ones. Saurav says, Open-RMF uses ROS bridge or not? Well, it does not. In general, it does not. You may need it to use it for whatever you need, but in general, not. You don't need it. Then Jess says, my company took the construct class on Open-RMF and found it very useful and informative. Oh, thank you, Jeff. So SB, thank you very much. I'm sorry, working with information from the person who took the class. Okay, so you didn't take it? Yeah, because I don't remember you, but somebody else, somebody from your team took it, and they explained. Okay, so you had to pay some license for that, yeah? Just joking. So happy to hear that your colleagues told you that it was very useful. For this new version, we have improved it a lot. For example, we have included the management, the integration of a real arm robot preparing the coffees that we didn't have. So we have to coordinate not only the two robots navigating, but also the robot arm. And also we have included the opening and closing of the door that you as a student has to manage to integrate into the system. So we have a real door opening and closing based on the commands that you will send through Open-RMF. And Lakshai Sharma says, how AGVs will get registered in Open-RMF? Okay, that's a too technical question here. So for that, you need to come to the online training because it's complicated. I cannot explain you. I told you the general thing that you need to create an adapter, and then when you launch it, then you configure some files and you indicate those robots, and that's it. So when you launch Open-RMF, it will automatically try to connect to your robot because it's identified in a configuration file. And okay, so here says, Jeff says, someone here used the Open-RMF tools to create a nice sim of our first floor lab. That's cool. And Shan says, Jeff, someone at the construct helped make the sim of the lab? No, we didn't, because with what they learned at the training, they can do it by themselves. So this training is teaching you how to apply this to your own projects. How you can see on the here on my background, how to add RMF to your own project. So after this training. Then, do you want to drive, is asking, when you define a speed limit or a driving orientation on a route, does Open-RMF share that with navigation as well? And yes, but I don't remember in which exact way. So there is a way to define this limitation. There is a way. So you can be sure that your robots are not going to surpass that limit, but I don't remember how now. Jeff says, okay, so he's answering Jan. Great. Okay, so let me see. Oh, okay. Tommy Wu says, how about an IoT device with MQTT message communicate with RMF? Still have to develop MQTT adapter? Yes, you have. Something similar. We have something similar for the door. So, and we are going to show you on the training if you want to come. Then in the door, we have a door that is been open and closed because the robot has to go to the other side in order to grab some stuff. Then this door has a Raspberry Pi that is connected to the same ROS2 network. And then this Raspberry Pi is connected to a relay that is connected to the door. So in some sense, it's like an IoT device. We can say that it's an IoT device. And we use a GPIO package from ROS in order to control that door. So you have to create that adapter for attacking that door. And that's one of the things that we teach you on the online training. Batatas Layer says, question, does the RMF use any market-based task allocation, the central? No, they use their own task allocator. And I did an interview to the leader of the Open-RMF, and it's in a podcast. Let me share the link with you. It's in the ROS Developers Podcast, which is, let me give you the link, and then he explains specifically about that point, that they created this task selector. And here is the one of Matthew Festo, and he talks about Open Robotics Singapore, who are the ones that have developed this project, this element. And let me see if I can find this. So, yes, the link of, I got it. Yes, got it. Here, I recommend you to check this podcast because he is explaining very well about the different parts of Open-RMF and their idea of the project, etc. So you can check this podcast episode. And what else? Let me see. Okay, thank you. Do you want to drive? Thank you, GT. Sean Christian Anderson says, is there an API where Aruco markers can be added as part of the commands issued by the Open-RMF? Yeah, so Open-RMF is not in charge of that. Open-RMF is in charge of coordinating the robot. So the specific skills of each robot that is able to do, like identify the Aruco marks, then they have to be implemented in the robot itself. So that has nothing to do with Open-RMF. So if you want your robot to recognize Aruco markers, then you can do it in a ROS way, for example, inside your robot, and then provide this functionality in your API some way to the Open-RMF. If you want, for example, to the robot to go to the place of the Aruco marker 35, I don't know. So there has to be a search behavior inside your robot, and that's called another task. And then this task, you can create your own tasks in Open-RMF. So Open-RMF already provides some tasks by default, like cleaning is one of the tasks already provided. Go to charge, that's another task. Or deliver, it's another task. So those tasks, they are already created and defined by Open-RMF, which expect to have your robot some specific skills to do those tasks, and to provide those tasks as an interface for Open-RMF to be called. So Open-RMF will say, oh, activate the deliver task, activate the go to charge, something like that. Okay, so you can create your own task if you want, and we teach you how to in this training. Yes, but can Open-RMF as command control software give the command to the robot which Aruko marker to go? Yeah. Okay. Yes. See. Can you give me an example, for example, for a concrete example, Shan? Batata Slayer says, thank you. Are you aware of an open source market-based task allocator for ROS? Open source market-based task allocator? What do you mean by that? By Batata Slayer, I don't understand your question. San Christian says, so Open-RMF can send a task to the robot to find a specific Aruko marker, and then another, it's based on task. Got it. I have 5 Aruko markers, and I need the robot to do a different task on each one. Okay, so you can tell the robot to go to a given Aruko marker, for example. And then once it's there, the robot will activate its task, whatever it is. For example, in our case, we tell the robot to go when he has to serve a coffee to a table, then he has to go first to the place where the coffee is going to be put on top of the robot. So, and then this coffee is being prepared by the robotic arm. So first, the Open-RMF tells the robot to go to the location where it's going to get the coffee. So the robot goes there, and then once there, the preparing coffee robot, which is an armed robot, is going to prepare. So it's been activated by Open-RMF and says, oh, now you do this. And once it's served, then Open-RMF says, okay, now go to the table to serve. So all those tasks, they are coordinated by Open-RMF. But the creation of the coffee by the arm is made by the arm itself. So it's not Open-RMF. Open-RMF is just saying, okay, start creating a coffee. Making a coffee, creating, okay? Okay, making a coffee. And then the robot is going to do it. Okay, got it. Market-based is a method of assigning tasks in a decentralized way. Okay, so I don't know about that. I'm sorry, Batata Slayer, I don't know, as you can see. But Jeff is answering you. That's what I understand and how it was told to me by the colleague who took the class. It's task-based and... Oh no, it's answering Shan. Okay. Then, what else? Okay, so guys, we are going to leave it here. We'll repeat this webinar in a month or so. So, and if you have more questions, you can wait to next month webinar. Then you can put the questions beneath this video, and I will answer you. I promise to give first priority to your questions and answer them for you. Okay, so that is all for today. Thank you very much for attending, for your so nice questions there and comments also, and you have been helping each other answering questions to some of the other people there. Thank you very much for all this, and see you around the world. Thank you. Bye-bye.